Hello, dear students. Hope you are fine. Today we will discuss some questions from past year papers from the topic of geometrical properties of circles. This question was set in 2018 November. Here are two circles which touch one another at the point C. Statement of the question is: the diagram shows two circles that touch at C. A, B and C are the points on the small circle with center X. C, D and E are the points on the large circle with center Y. A, X, C, Y, E and B, D, B, C, D are the straight lines and Y, D, E equal to X. In part A, we have to prove that the triangle BCX is similar to the triangle DCY. Give a reason for each statement you make. In this figure, this is the triangle BCX and the other one triangle is DCY. These two triangles, we have to prove that these are similar to one another. Over here at point C, these are vertically opposite angles. The angle XCB and the angle YCD are vertically opposite angles. Secondly, both of these triangles are isosceles triangles. Over here in smaller circle, XC and XB are the radii of the same circle. In the same way, in the bigger circle, YC and YD are the radii of the same circle. So this way, these two triangles are isosceles triangles. In this smaller circle, the angle BCX is equal to the angle CBX because of isosceles triangle. And in the bigger circle, the angle DCY is equal to the angle YCD, right? So the angles CBX, this angle CBX is equal to the angle CYD. So we are justified to say that the triangle BCX is similar to the triangle DCY. Why? Because two corresponding angles are equal. Angle BCX is equal to the angle DCY. Why? Because of vertically opposite angles. Now we see that the triangle BCX and the triangle DCY are isosceles triangles. In the triangle BCX, angle BCX is equal to the angle CBX, and in the triangle DCY, angle DCY equal to the angle CDY. So the angle CBX equal to the angle CDY. Hence the triangle BCX is similar to the triangle DCY because the corresponding angles are equal in measurement. Now in part B, find in terms of X, number 1 angle DCY, number 2 angle BXA. To find out angle DCY, in this bigger circle at point D, the angle CDE is a right angle. Why? Because this is angle in a semicircle, right? So the angle CDY should be 90 minus this x. And you know, this angle this triangle CDY is an isosceles triangle, so these two angles would be equal in measurement, the angle DCY and the angle CDY. So we are justified to say the angle DCY is equal to 90 minus x, right? Angle CDE equal to 90 degree because angle in the semicircle. So CDY equal to 90 minus x. Angle DCY equal to the angle CDY because the triangle CDY is an isosceles triangle. So the angle DCY is equal to 90 minus x. In this second part, we have to find out angle BXA. Here in the figure, angle BCX is equal to the angle DCY equal to 90 minus x. You know, the triangle BCX is an isosceles triangle, so the angle at point B, the angle CBX is equal to the angle at point C, the angle BCX. So BCX is equal to CBX. Angle CBX equal to the angle BCX because the triangle BCX is an isosceles triangle. So CBX is also 90 minus x. Now the angle BXA is the exterior angle of the two internal angles of the triangle at angle B and at angle C, the angle XBC and the angle XCB, right? Angle BXA equal to the sum of angle CBX and the angle BCX. Why? Because exterior angles of a triangle. So BXA equal to sum of these two. Each one was 90 minus x. So BXA equal to 180 minus 2x. This way we have found the angle BXA. It is given that BC equal to 3.5 centimeter, CX equal to 3.2 centimeter and CD equal to 5.6 centimeter. We have to find out the length AE. You know, this is the case of similar triangles. So in the figure, you know, the triangle BCX is similar to the triangle DCY. Now we calculate the unknown. You know, the triangle BCX is similar to the triangle DCY. You know, the ratios between the corresponding sides of the similar figures are equal. So CY by CX is equal to DC by BC. Now we put the values. So CY is calculated as 5.12 centimeter. We were supposed to find out AE over here. So according to the figure, AE equal to AC plus CE. Now putting the values, we were supposed to find out this AE, and AE is equal to AC plus CE. This AC is equal to double of AX because X is the center of the smaller circle, and this CE is double of the measurement CY because Y is center of the bigger circle. To calculate AE, we have put the values of Cx and Cy here, then multiplying 2 with this one and 2 with this one. This way we have calculated AE equal to 16.64 centimeter.